This lesson, we are going to introduce the idea of optimization. Optimization means we are trying to maximize something or minimize something given certain constraints. So like we may be trying to minimize a cost given certain constraints, maximize a volume given certain constraints. Example might be a structural engineer is trying to maximize the strength of a beam, but you have a certain cost that you have to kind of adhere to, right? So you can't make the beam crazy, crazy strong, but it has to do what it's supposed to do within that certain cost. Airline strategist might be finding the best allocation of all the airplanes at certain hubs to minimize the cost while trying to maximize passenger miles. So somebody's behind the scenes figuring out how to do all that sort of stuff for that company. So our example, first example we have is we have a rancher that has 400 feet of fence for constructing a rectangular corral. One side of the corral will be formed by a barn, requires no fence. So here's the side of the barn. 3 exterior fences and 2 interior fences partition the corral into 3 rectangular regions, as shown below. What are the dimensions of the corral that maximize the enclosed area? And what is the area of that corral? So I like to kind of organize what it is that we're trying to do. So we are trying to maximize the area. So max area. So we need some sort of an area formula so that we can do some calc to it. So if we're looking at this rectangle, we have, if we ignore these inside pieces because we just have a rectangle with dimensions x times y, our area formula is x times y. So for this, for us to use some calc, we're going to take the derivative of it, set it equal to 0, find a critical point, find maxes and mins, because we're looking for a maximum. The problem is that we have a formula that has 2 variables. I really don't want to do an equation that has 2 variables. So let's see if this constraint that we have is going to do something to kind of help us sub out one of the variables and then do our derivative. So it says that we have, the rancher has 400 feet of fence. So fence, 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 fence. So the perimeter is, or we have 400 feet that's going to consist of x, 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 and x. So 4x, x plus x plus x plus y. Wonderful. We have some sort of other equation that we can use to do some sort of a substitution. So between the two, I could technically try to isolate either variable, but y is going to be much easier than x. So to isolate y, we would pull the 4x over. So 400 minus 4x equals our y. And that is now something we can substitute. So there's our y value, and let's go ahead and distribute so that we can do a derivative to it. So we have 400x minus 4x squared. And then we'll do our derivative so we can try to figure out a maximum or a minimum to it. We're looking specifically for a maximum. So we do our derivative. We do the derivative of 400x is 400 minus 8x. We'll set that equal to 0. And let's bump the 8x over. So 400 equals 8x. Divide by 8. X is going to equal 50. All right, so we got our possible answer, but let's make sure that it's a maximum, right? It's a critical value. It's a slope of 0, but I don't know if it's a max, a min, or just a spot that it levels off. So if we have 50, we're going to take, here's our derivative equation. And if we plug in a value that's smaller, like a 0, we're going to get 400 minus 0. That's going to be a positive. And then on this side, we plug in something like 100. We're going to have 400 minus 800 is going to be a negative. So we definitely at 5 or at 50, we're going to have a positive slope transitioning to a negative slope. We definitely have a maximum. Great. So 50 is at least the x value, but we want the dimensions. And then we're going to actually figure out what the overall maximum area is. So we have this equation that once we know our x value, we can plug it in to figure out what our y value is in relation to the x's. So we have 400 minus equals 4 times 50 plus y. And actually, we have a better equation. We have this equation. So 400 minus 4 times 50 is going to equal the y value. All right, so that's 200. So 400 minus 200 equals our y value. So our y is 200. So dimension-wise, our dimension is a 50 feet. So 50 feet by 200 feet. And then that gives us our maximum area of 50 by 200 is going to be 10 with 3 zeros. So 10,000 square feet of area from this dimension. If we were to do any other kind of dimension, if we made this 40, 40, 40, 40, and this whatever, and then we multiply that out, we would not get a value that's any bigger than 10,000. So that's the best that we can do. Those dimensions are the best, and that's going to give us the maximum amount of area.